none of the significant environmental problems we've dealt with have been dealt with without some kind of technological fix. And none of them have been dealt with without a social fix. It's always both.
Hey, humans! Welcome to Demystifying Science. We're on our way to Earth as part of a maintenance mission for the Intergalactic Science Alliance.
Yeah, we have the Flossians. Haven't been to your planet in a few thousand years. Some of the drones we left last time need a little bit of attention.
Sure do. So, we decided to make the most of the journey by studying you humans in our free time.
Today, we jumped on the entanglement crystal and rang up Dr. David Keith. He's a professor of applied physics at Harvard who is an important player in the controversial field of solar geoengineering.
His studies are focused on ways that humans can control global temperature over the course of the next few centuries.
That's the geo part of geoengineering. Keith and his colleagues recognize that in the future, humans might need to control climate in order to save modern agriculture or urban infrastructure.
Especially because humans don't seem very keen on the idea of moving whole cities or inventing new kinds of food sources, both of which will be necessary if global temperatures continue to rise.
So we talk about a few different manifestations of the technology he studies. Reflectors placed in the region between the Earth and the Sun called the Lagrange point.
And dispersion of solar aerosols. This kind of technology that humans fear is already in place in the form of chemtrails.
Not according to Keith, though. He says that no one is actually practicing solar geoengineering on Earth.
Not yet, anyways.
Exactly. Right now, all the work is theoretical. So we explored the risk versus rewards of these potential technologies, as well as funding and implementation.
Dr. Keith also shared interesting ideas about the politicization of words like climate, natural, and CO2.
It was a great discussion, if a little short. We think that you'll find Dr. Keith's ideas compelling and his commitment to responsible engineering quite refreshing.
So, help us out to bring more Earth thinkers in the future. Give a like and subscribe. It's invaluable to our sense-making mission.
Enjoy the episode, humans. We'll see you next week.
Take care.
Bye.
So, you're a geophysicist?
No, he's a solar geoengineer.
Oh, geoengineer.
I certainly am not.
Oh!
That's reading words.
We got the wrong guy.
Uh-oh.
Yeah.
Well,
I've done climate science my whole career.
Okay.
But in this debate about solar geoengineering and whether we should take it seriously, I think most people like me who are engaged in research would run away from the idea that we were geoengineers. After all, nobody's actually doing this now, and it's not a field.
really? Nobody?
Well, let's go back a little bit. Can you tell us a little more about what solar geoengineering is?
Solar geoengineering is the idea that humans might deliberately do something to make the Earth a little bit more reflective so that a little less heat is absorbed from the sun, so that we have less climate change for a given amount of carbon dioxide in the atmosphere.
And the science for this is based on humans that have decided that carbon dioxide is the leading cause of heating on your planet, right?
I'm not too happy about putting it that way. I'd say the very strong evidence that we have is that if you're asking for how the climate is changing over the last half century or how it will change over the next century, that will be dominated by human action. And the human action is building up these long-lived greenhouse gases, of which CO2 is the most important one, that trap heat, make it harder for the Earth to radiate out. And that will tend to raise the surface temperature, make other changes. So Yeah, that's the dominant cause as best we understand it. And especially since it will be the dominant cause over the next century.
And
So, what's so bad about heating?
mm,
Nothing's necessarily bad about it at all. I don't think there's anything inherently good or bad, but and there's nothing inherently good or bad about this climate compared to some other climate. But humans and the natural world have evolved to the climate we're in, and if the climate changes very quickly, that's a bad thing because, say, the location of our cities on the coastlines or the kind of crops that we grow are adapted to the current climate.
and humans aren't particularly good at quickly responding to these sorts of changes, right? You're sort of stuck in your ways in some fashion.
I think there's a big difference between local and global.
Mm-hmm.
So, humans maybe like every other species, is lazy and wants to just keep on doing what it's doing. But if you've got a local pollution problem, like people's poop piling up in the streets before we had sewers, or like air pollution, and the problem is pretty local, then it's not easy, but you can get a deal where people agree to spend money and do work to clean it up. I
So,
think the,
go
the
ahead, go ahead.
problem the problem with CO2 is that it's not locally a pollutant and that it builds up over time, over a century or more, and that it doesn't make any difference where it's emitted in the earth. So, in the earth where there are tribes of us, and if one tribe spends a lot of money to stop putting CO2 in the air, the benefits of that go to everybody. So it's hard to get a deal.
And what is the mechanism for reflecting the heat that scientists are proposing at this point?
So there are a bunch of different mechanisms, maybe going down from the top to the bottom. You could, in principle, put big reflective structures, giant mirror-like structures in orbit, especially at this Lagrange point, the stable orbit place between the Earth and the Sun. You could add fine particles, aerosols, or just a fancy name for things that are small particles that don't fall really quickly. You could put those in the stratosphere. That's an area about 20 kilometers over our heads where material will stay for a year or two. You could add some other kind of particle to some thin high level clouds called cirrus clouds that might make them thinner. You could add still another kind of material, salt spray, to low level clouds to make them brighter, or you could just make the surface whiter. So there's a whole bunch of these ideas.
And where are people putting most of their thoughts right now? So this is a weird field, right? Because there's not that many fields where there are scientists studying the thing, but no engineers or technicians actually putting it into action, right?
There are lots of things that we study that we haven't done yet and may never do. And of course, people study things in detail that they hope will never happen. So, there are friends who work on how to manage an Ebola epidemic or a bioengineered smallpox attack or nuclear war. And yet, presumably, all those people hope we don't have a nuclear war or a smallpox attack.
Well, there's some pretty
So,
big debate on Earth about whether or not they should be studying the smallpox and giving gain of function stuff to it, right?
that there's yes, so there's debates about how to talk about it for sure. I think that there's a widespread view that it's worth complicated, but I'd say there's lots of things people study that they don't necessarily do or ever will do.
And so, in the field of solar geoengineering, what seems like people actually are going to do? Are people going to do this? Is this going to happen?
So that's fundamentally a political question, not a scientific question. I mean, some of all my answers, I have no idea. Um, I think at different times, I both think it's likely to happen in the next 50 years and unlikely. But I think our job in the scientific world is to do our best to understand what the risks are and how well it could work, and then to begin discussions of how we might govern it. But I think it's not our job as scientists to say whether it should or shouldn't happen.
Who would be implementing it if it were to happen?
Presumably governments, some coalition of big governments.
Okay. And so you have a couple of different options, right? You have this Lagrange point where you have something out in space that's between the Earth and the sun, and it's blocking some of the radiation. That
Yep.
seems easily reversible, right?
All these things are pretty easily reversible in terms of their direct sun blocking effect. But yeah, the Lagrange thing is very quick to undo. To be clear, I don't think that's relevant for the next half century or so because we don't have the technology to put large structures at Lagrange point in the next half century. But there's reason to believe that's not crazy if you look ahead over the next sort of second half of the century.
So if human civilization doesn't fall apart in the next few years, then the Lagrange point becomes optional.
I think that's right.
Okay. So what's the nearest term?
For sure, the thing that is most easy to do with current technology without any innovation that you could actually start doing basically now would be to put sulfuric acid aerosols in the stratosphere. And the reason the stratosphere is because things mix evenly in the stratosphere and stay there for about a year and a half or 2 years, which turns out to be a kind of useful time. And the reason sulfuric acid is we have this huge experience with nature putting sulfuric acid in, and it's actually pretty easy to add SO2 from an airplane, which turns into sulfuric acid. So there's both a technological ability to do it with existing hardware and some confidence about how it would work because there's been half a century of people studying these sulfuric acid droplets in the stratosphere.
I put sulfuric acid in my coffee one morning. It wasn't good for my teeth.
Yeah, exactly. So it's not. I think actually I kind of like the fact that sulfuric acid is the big topic here because it sounds scary and awful. And my worry is often that people will take this idea too seriously. We can get to why, but I think it's actually kind of good that sulfuric acid seems scary. It makes people less likely to think this is all happy.
Is it corrosive?
Pardon?
Is it corrosive?
It's intensely corrosive, and sulfuric acid droplets that we put in the lower atmosphere kill about 4 million people a year right now. This is the pollution that we pump in the lower atmosphere. So
that's a byproduct of industrial processes or something?
Yeah, burning fossil fuels, and fossil fuels have large amounts, some of them have large amounts of sulfur in them. And that problem goes way back. I mean, the first government regulation that I'm aware of that tried to ban the burning of high sulfur coals was a proclamation by the king in London in the 10th century. So problems with sulfate aerosols are not new, and attempts to regulate them are not new.
What was his motivation?
Air pollution.
Okay.
I mean, heck, there was the Bankside coal plant in London. First had a sulfur scrubber installed in the century before the last century. That is the later part of the 19th century. So these are old problems. But the sulfur we put in the stratosphere would be the same sulfur. It would have some air pollution consequences, but because it's even and because it gets rained out, it turns out that the air pollution consequences seem like they'd be very small. So to be clear, if you wanted to deal with this solar geoengineering idea, you might put like 1 million tons a year of sulfur into the stratosphere, whereas right now we've been putting something like 50 million tons a year into the lower atmosphere as part of industrial action.
Can you just reroute it?
Oh, that's really interesting. Can you put like big fans up there to like get things into the stratosphere?
No, you couldn't. Then it would have to be fans so big enough to disrupt the whole circulation of the atmosphere, which is not a thing you'd want to do.
That's probably a good point. So
Yeah.
The idea is that humans are
Because
already...
the whole point of this is to reduce the amount the climate changes, at least from my point of view. The point of all of this is to reduce the amount of climate change that we get for a given amount of greenhouse gases. And to be clear, in the end, we have to stop putting greenhouse gases in the atmosphere for sure. And we may want to take them out if you want to avoid really disastrous climate change. So at best, this idea is a supplement to cutting emissions, not a substitute to cutting emissions. You have to cut emissions. And it's imperfect. It has all sorts of problems. So it would be much better if we could just magically take all the emissions out. But we can't, because the emissions have accumulated over time, and we can't just magically make them go away. Even if we stopped all emissions of carbon dioxide tomorrow, the climate problem wouldn't be solved. We would just have stopped making it worse.
But what if you plant a lot of forests? So let's say you stop emissions. Let's say that I was looking at, I think I heard you mention Oliver Morton's book somewhere else, and so I started looking at it, and he's talking about this idea that you would need to open some crazy amount of nuclear power plants. I think he says something like 1 nuclear power plant a week for the next 40 years to make up for all of the coal and combustible fossil fuel stuff that humans are using right now. But let's say that you do. Let's say that...
Or solar power. I think those are the two big ones. It's not clear it'll be nuclear, but yeah.
Sure, or geothermal, or something that harvests ocean waves. There's lots of...
Yeah, but actually there's big differences. Geothermal is very hard to do without having a big local impact, and ocean waves are just not enough energy. You can't, it's more or less, I can rule that out from basic geophysics. There's too much impact. No, I think if you're really talking about energy sources that you can scale to power an industrial civilization that needs 20 or 30 terawatts of carbon-free power, I think there's really only 2 that are scalable to that scale without having huge environmental impacts, and that's solar and nuclear.
All right. So let's say that...
I mean, the other ones, like all, if you do all the hydro in the world, dam every river that there is with huge environmental impact, you get like 2 terawatts.
So this is just a question of cost benefit.
Well, in some cases, it's like hydro. It's not cost benefit. You actually, there's only about 2 terawatts in all the hydro in the world, and we're already using 15. So hydro can't do it. And some of the other things, you could do it all by biofuels, but only if you turn the entire world into an intense biofuel plantation with huge environmental impacts. So,
and biofuel is where people grow things and then they burn them, right?
Yeah.
And this is corn and wood. This has been somehow sold as a greener alternative to coal, yes? It has such a green name.
I find that somewhat bizarre, since the reason we switched to burning coal in, say, well, in Britain, it was about 1790, was when Britain became dominantly fossil powered as opposed to wood powered, was basically because all the trees had been cut down. It was, and that's not really much of an exaggeration, and it was a kind of environmental holocaust. So I'm very skeptical about the idea that large-scale use of biofuels makes much sense if you're trying to solve an environmental problem. If you're trying to create a problem, it might be a good thing.
That's very true. But so to get back to the sort of the root of this question, so let's say that you managed to get off of biofuels, you managed to get off of coal, natural gas, all these options. You have nuclear and solar. Could you have natural approaches for getting rid of the carbon dioxide just by planting trees, regenerating coastlines, helping the oceans fill with plankton again, algae? Is this an option?
Some of those things. I think calling them natural is a little unclear. If natural is what nature does when it's left to its own, then things that we do by changing things almost by definition can't be natural. So you could have the nuclear power plants or solar power plants running desalination farms, which filled the Sahara with fast-growing trees and keep growing them and cutting them down and burying them, and that would take carbon out of the atmosphere using trees. But to me, it would certainly not be natural or environmental.
So this is an interesting question because you seem to have the opinion, which I've heard many humans express, that humans are not natural. And the activities of humans aren't natural. This is sort of a rabbit hole.
Well, it's like you can only delineate between things humans do and things they don't do. So, one, they probably make sense they call themselves what they do artificial.
I think it's useful to think about the natural world that we evolved out of, and obviously even our brains are shaped by, and our bodies are shaped by, and we're part of, but the way that world was before humans really modified it so much, and the way it is now. And say when humans are really modifying that world, either just by making a mess or by modifying it deliberately, that is somehow unnatural. And it is a disputed boundary, but I think it's a meaningful boundary. So I think if we decide as a species that we want to have very high productivity of total the biosphere, maybe we want to actually put more CO2 in the air, geoengineer the climate to be pretty flat, equator to pole. Maybe that would have higher global productivity, but it sure as heck would not be natural. And similarly, when we just make a mess by throwing metals or mercury or whatever into the environment and destroy things, that's not, in my opinion, natural.
Mm-hmm.
So I think there still is a meaningful distinction, but it's fuzzy.
What
I
about
mean, a question that's sort of similar to the question of geoengineering is: should we reintroduce extinct species that we recreate through genetic methods? Is it natural or not?
well, if you want to? But I like how you point out that nothing's really natural that humans are doing.
Yeah, but I think the cop-out version of that is to say, well, if we're part of nature and nothing's natural, then it doesn't matter at all.
Well, that's
And
ridiculous. You have to
I don't
you
buy
have to
that.
have standards for quality, right? For
I
your
would-
own quality of life.
I would say that what humans do is very natural, and it's just not very well adapted.
Just
Like-
depends how you define natural.
You guys are adapted in such a strange way that it seems like your only option is to drive yourselves into extinction unless you start to realize that there's other ways of doing things. Like the foundation of their civilization is growth and progress and more and bigger and all these sorts of things, right? And that just seems like a very animal quality that went out of control.
Well, it might work out for them.
We had a really interesting conversation just recently with someone who was studying something called the bicameral mind. Have you ever heard of that, Dr. Keith?
Sure. Just the idea there's two halves of the human brain, and they have slightly different functions.
No, so this is related to that, but it goes back farther, which is that it used to be that the left brain and the right brain were different identities almost. And back in the day, during the late Bronze Age, the voice of God was it the left hemisphere? It was in one of the hemispheres, and it would talk to the other hemisphere. The other hemisphere would hear the voice and would think that it's the voice of God. And then all of a sudden, humans developed this idea of the I, the internal quality of the self that allows them to think and plan for the future.
Well, I'm no expert. There are clearly humans who think they hear the voice of God. But I would say that I don't think this is just about human survival or extinction. I personally think there's a value to the natural world that's beyond its direct value to humans. I think other humans think that too, not all of them. And I think that there are ways in which climate change is a threat to humans. For example, just to come back to your original question, high temperatures kill people. And people are less productive, and actually people are dumber at high temperatures. Pretty easy to show from data. So there are clearly lots of direct bad impacts on humans of too much climate change. But at least for me, I don't think of the total climate problem as just how humans hurt themselves. I also think about leaving more of the natural character of the world to our, for the future.
Mm-hmm.
What about just moving all those industrial processes off the planet?
Well, in the very long run, that might be a thing to do, but none of these technological fixes happen without a choice. So things don't just do themselves. They happen because people want to solve problems. And for the kind of pollution problems I work at, people often like to make a distinction between technical fixes and social fixes. And I think that distinction is often pretty silly. Because the fact is, none of the significant environmental problems we've dealt with have been dealt with without some kind of technological fix. And none of them have been dealt with without a social fix. It's always both. These problems don't solve themselves. They require social decisions and political battles to fix, but they also require technologies. So if you think why we don't have shit in the street, that didn't just happen. We had this complicated set of technologies and social decisions that gave us the sewer system and modern sanitation. And it's always both.
How do you incentivize good behavior, though? Or in this case, how do you incentivize the processes, the technologies that are going to lead to implementation of anti-warming strategies?
Well, so let's circle back to let's circle maybe back to this topic. So I don't know how to incentivize good behavior. I don't even know how to do that for my kids. But I think one of the problems is there are people who oppose even doing research on solar geoengineering because they're worried about some bad outcomes that I think are reasonable to worry about. But my view is that we don't try and solve all problems at every step. And humans really specialize in different things. And those of us who work on the science technology need to be involved in the public policy, need to listen to what the concerns are who are trying to solve a problem. But ultimately, what we're making is knowledge. And that knowledge does not directly hurt people or not. It gives people choices. And I think it's important to be clear about that. And let me come back to what I think one of you, the dark one, said about Quinn said about referring to smallpox. So my general view is that in most cases, more knowledge isn't bad. I don't think that's always true. So I think there's some things where more knowledge, if it's so dangerous and so likely to be misapplied, might be bad. So finding out really cheap ways that anybody in their basement can make smallpox is, I think, knowledge I'd rather have secret, rather have it held by just, frankly, a few insiders who are working to protect the world from crazy people. But solar geoengineering doesn't feel like that. It's something that, if it ever gets implemented, is inherently kind of slow. It takes many people. It's visible. It's not likely to be done by some single nut in the basement or single billionaire. And there really are, it appears, some really large benefits as well as big risks. So my view is just knowing more is a good thing. And principally what I and other scientists are trying to do is simply know more about it, find out more about it, figure out ways it could work.
Are there any incentive structures to get technologists involved in this process? Is there any reason for a company to even want to develop that technology?
I think in general, this shouldn't be done in the commercial world. So solar geoengineering at least appears to be so cheap that it's not like we need capitalist competition to make it cheaper. Of course, if you actually implement it, there will be commercial technologies involved, as there are for anything. So the airplanes or the satellite monitoring systems or whatever, but it's not a business in the normal sense. I think it'll be done by governments. And my view is that the research should mostly be done in not-for-profits and in a way that is open access, not for profit.
Is there any chance that there is an unknown actor that is already attempting to do this? That is already testing it?
Yeah, I think the answer is pretty close to no.
Okay.
But it's interesting that a lot of my fellow humans think differently. So if you poll Americans, you find that something like 30% of them answer yes to a question that's something like, is your government spraying toxic chemicals from airplanes as part of something called chemtrails? And depending on how you ask that, you don't use the word chemtrails, you get a significant fraction of the population thinks it's true. And so significant numbers of people who, some of them confronted me on the street, actually believe their government is deliberately putting poison in commercial airplanes for mind control or just to kill everybody, or I don't know, they have all sorts of reasons. And those people have kind of conflated this idea with the idea of solar geoengineering. So what the mass of people actually believe is quite astonishing.
Yeah, do you know Mick?
People believe it.
Sorry, do you know Mick West?
Yeah, I've communicated with him once or twice. He's terrific.
Yeah, we actually had him on the show a little while ago. I don't think we've released that episode yet, but
yeah,
it's kind of astounding that he's still arguing with people about this.
Well, but remember, lots of Americans also believe that 9/11 was an inside job by some Jewish cabal, or all sorts of just completely things that seem to me to be just nuts. And I mean, nuts is to have essentially zero chance of being true. And I think the important thing is, it's not that I'm assuming people all have goodwill, or I'm assuming our government is made up of people who are all honest and doing the right thing. In fact, I don't think that's true of our current government or any. But I think that big conspiracies like that, the experience is they just can't be kept secret.
Well, it's interesting because
so it just doesn't happen.
The U.S. government does have some history of spraying things on people, right?
You mean on the micro scale?
Yeah, they sprayed a bunch of bacteria on San Francisco. What was it, back in the 50s? And
well, those are examples, yeah, or something closer to climate. The U.S. government attempted to do weather control by spraying weather control agents over the part of between the North and South Vietnam border, over the so-called Ho Chi Minh Trail.
That's
during
right.
the Vietnam War, and that led to a UN treaty against the use of weather and climate modification techniques for warfare. So no, there's reason to be, these things aren't, it's not baseless to assume the governments would want to do things like this. What I think is baseless is to assume that you could do some massive thing like having all these aircraft with huge amounts of material moving around and have that all be secret in the middle of a kind of civilian period because somebody would tell. I mean, remember, even in the middle of the Manhattan Project, the core knowledge about the configurations of the high explosive lenses, the Russians knew that before the Trinity test. Like, humans are just not good at keeping secrets.
Good point.
So for developing something like this, what are the biggest risks that you can imagine as somebody who studies this for a living? Like, what keeps you awake at night?
So the biggest overall risk for sure is not technical. The biggest risk for sure is the risk of it being misused, and it being misused by serving as an excuse for people to not to cut emissions or to cut emissions more. So what I think we know technically is that, well, a combination of emissions cuts and some kind of well-managed, or not even only partially well-managed solar geoengineering might have significantly lower risks and make people like less likely to die and make ecosystems better off than a world with just the emissions cuts. But the big worry is that, in fact, that's not the two worlds to compare. The big worry is that, in fact, in a world with solar geoengineering, people will be less incented to cut emissions, and so emissions will be higher, and the overall risk will be higher, and so the risk reduction won't really make things better.
So this will act...
The moral hazard, we call it.
That sounds a lot like building new medicines for people that de-incentivize them to take care of their bodies.
There are enormous examples of what we call individual risk compensation behavior, where if you introduce a potentially risk-reducing technology, people sometimes take advantage of that technology to take on more of the risks to do things that they want.
Yeah, it was interesting.
That's not necessarily bad or morally wrong. So, like, I do lots of climbing. Nowadays, climbing ropes basically don't break. And so you can afford to do climbs where you fall a lot because there's the chance of a consequence is very small. If I was climbing on old hemp ropes or the older nylon ropes, I wouldn't be doing that. So that risk compensation works. And there's tons of examples.
I got a climbing gym on the ship too, Dr. Keith. That's pretty awesome. I haven't met a human that likes climbing as much as me yet.
So, but back to the idea of these ropes and that it will allow you to go beyond what previous generations were able to do. Have you seen the movie Snowpiercer?
I have not.
You have not? It seems like it was made for you.
Yeah, I know, but I haven't seen it yet. I should.
I'd skip it if I was you.
Yeah, you're not missing too much. But the idea is...
I've seen some of his more recent movies, but the wonderful one about the Koreans with the other couple living in their basements.
Parasite.
That was awesome.
That was excellent.
Yeah, Parasite. I saw Parasite, which was terrific.
Well, Snowpiercer actually wasn't really that fantastic of a movie, but the idea there is that Earth attempts to do solar geoengineering and they cause eternal winter. Yeah.
So I don't know any... I think it's almost impossible to think of a scenario where that really happens. Now, of course... some listeners of this may say, well, almost impossible. I mean, it can happen. But I think it's important to say our world is filled with technologies that could be abused. And there's no question this is one of them. But I think you can think about technologies that are more or less likely to be abused. And at least the version of solar geoengineering that I most work on, which is putting aerosols in the stratosphere, you can't target it. It turns out that sort of inherent to the way the stratosphere flows, you kind of have like 2 or 3 knobs. You can put more in the south or more in the north, but you can't target in one area, just hurt one group. And it's kind of slow moving and it's visible. So I feel like as a technology to be abused, it's abusable, but a lot less abusable than lots of other technologies. So, I'm talking to you through this device we call a computer and a laptop, and these devices and some of these mechanisms can be used to throw elections and to do all sorts of terrible things. And there are technologies similar technologies that can be used to make killing machines. And there are technologies people work on that are life-saving that also can make deadly poisons. So I think in the end, humans need good governance to manage technology. But I it's not like I want to be dismissive of the governance problems about solar geoengineering, but I think sometimes people think about them in a vacuum, as if there's no other governance problem out there. And I think it's, as compared to many other technologies, relatively hard to abuse.
I think it's really fascinating how you distinguish between science and technology, and you see yourself as really interested in understanding the processes here. On our planet,
Well,
we
I didn't say that right, though, because I do think this, I don't think, maybe I didn't say it right. I think that really classic science is about figuring out, if you like, how nature works.
yeah.
So, why hummingbirds have the bill that they have, or, why the top quark is the way it is. And technology is about applying science to serve some end.
Yeah.
And I do think that solar geoengineering is fundamentally a technology. A lot of people don't like the idea of calling it geoengineering. They want to call it something else, which is fine. But I think it, and people often don't like it because they say engineering is always precise. I don't think engineering is precise. Engineering is pretty sloppy. But engineering is about applying science to achieve some goal. And that is very much what this is.
So you see yourself as an engineer that's just not commissioned to build an application yet?
I do see myself as a little more of an engineer than a scientist, I would say, in the sense that I've always done applied science or public policy my whole career. So I have very little of my effort is trying to understand how nature works better.
That's interesting. Because it seems like you have to understand how nature works in order to interact with it.
Of course. So it's always yes. So it's always both. The question is like, what's your main goal and what's the subsidiary goal? So yeah, so another particle you put in the stratosphere is calcium carbonate, and we published some papers showing how this could be better and help the ozone layer, but there's a bunch of things that are wrong with our paper. You actually have to go understand how real calcium carbonate would actually interact, and so we've got a laboratory experiment to do that, and that quickly gets you down to questions that are sort of about how nature works, and how does the acid actually go in the little cracks of the calcium carbonate particle. But that's, to me, still that's getting to be something that's more like a science question, but it's kind of driven by an overall technology or engineering goal.
Did you come up with that one while you were using some climbing chalk?
Yeah, we've wondered about that. That's magnesium carbonate, actually.
Oops.
Not calcium. But I've wondered about toxicity of climbing chalk. There's actually several papers about it because, it sounds like you climb a bunch in gyms that can be pretty filled with there's a high density of those particles in the air, and you got to wonder about toxicity.
I've always been more concerned about the shoe rubber, actually.
In the air?
Oh, well, yeah, because it gets rubbed off, especially, I think you humans have those, Walltopia walls.
I get
sandpaper.
worried. We really are getting on a tangent. I get worried about destroying nature. So I live in an area right up there that's got lots of limestone cliffs.
Wow.
And there's great climbing right out my window. And with limestone especially, it doesn't take that long of a lot of people climbing on it until it all gets slippery. And people have experimented with ways to reverse the slipperiness and not succeeded. And so I wonder if it's kind of a non-renewable resource. People develop new climbs, and then after a while they get so slippery they're not really fun to climb anymore. And I think that's to do with some interaction of shoe rubber and the little micro spikes in the rock. And it doesn't happen so much on granite or gneiss or something, but it happens on limestone a lot.
That's
Interesting. Yeah, we're stuck with this gem on our ship right now.
Well, maybe one day when we get to Earth, we'll find a nice limestone cliff and we can live at the base of it.
Can't wait.
Yeah.
Is that how all scientists live on Earth? You live at the base of limestone cliff?
I'm lucky to be in the base of it. But now with the pandemic, I can do this remotely and still live here. Now the climbing season is ice climbing season is about to start, but the rock climbing season has kind of just ended in the last few weeks here. There's a fair amount of snow on the ground.
What a world.
It's sad.
But to loop us back into this conversation, though, that is less about climbing gyms and more about the atmosphere, what do you make of the supreme focus on carbon dioxide to almost to distraction, it seems like?
Is carbon dioxide the best metric for pollution?
Not for pollution, but for climate pollution, yes. So I'd say if you're thinking about long-run climate change, especially climate change on a century timescale, CO2 really is the right thing to focus on.
So this is...
People also worry about methane and a bunch of other things, But in the long integral, CO2 is the one with the long lifetime. It's the one that's hard to deal with. It's the right one to focus on. Now, of course, if you're talking pollution, air pollution, water pollution, those are different stories.
And I
Are
guess
they bigger stories?
that's the question that I'm trying to ask, right? Like we talk about with other humans what happens to the fish in the oceans, to the coral reefs, to the forests. We have all these discussions about the environment falling apart, and much of it seems to be related to environmental changes, and humans are putting out so much trash, so much pollution, so many plastic compounds and insecticides and pharmaceuticals.
Herbicides.
So that's a great question. Here's a couple different perspectives. If you ask, so you got to have the right measure. If the question is, what environmental pollutants are hurting humans the most today? The answer would not be climate, it would be air pollution. So we estimate that air pollutants kill something like 4 to 6 roughly million people a year globally today. And that's much bigger than the number from climate.
That's fascinating.
If you ask, in what ways are humans most harming the real kind of natural characters of the world, it's probably the expansion of human activities on the landscape and also climate. If you ask what will be the impact over 100 years, climate looks more important. And there's another fact. Lots of us humans are on our, I don't want to say solving, but are at least have turned the corner and are on our way to solving a bunch of the local environmental problems. So air pollution is bad. Air pollution has actually got better in not just the developed world, it's got much better in the rich world, but it's got much better in China now. And it's still a big problem, but it's a problem that's clear we're kind of on a pathway to solve. I wish we were solving it faster, but we are. And, say insecticides. My father was actually a leading person who worked on DDT. DDT was a insecticide whose breakdown products, DDE and DDD, have these propagated in the food chain and have these really big impacts. But we've largely regulated those out. And the new insecticides are still bad, but they're a lot less bad. And by lots of measures, the impacts are much smaller than they were in the 60s.
But DDT is still being used in plenty of countries, right?
Total amounts are much smaller.
Gotcha.
And it actually turns out that it's particularly useful as an anti-malarial inside bed nets and so on. It's probably good for humans to use it for that. But the big picture is for lead in the environment, for example, or DDT or global ozone, or many measures of air and water pollution, we have made real progress. And in some cases have really turned the corner and have made things better. In other cases, we've at least stopped them getting worse. But the big one that's global, where we've made almost no progress, is climate. Because climate depends on the cumulative emissions of carbon dioxide, not the amount you emit each year, but the cumulative emissions. And right now, the amount we emit each year is still going up. So the cumulative is going up really fast. And because of that long footprint, because of how global it is, I think it is right to think of it as a really serious problem. But I agree with you. So, in answer to your question, when you're thinking climate, is it right to think CO2? Yes. When you're thinking environmental problems, is it right to think of climate as being the be-all and end-all of environmental problems? I think the answer is not. It's not simple. It depends on value judgments, depends on... No, it's not a simple answer, but it is a big one.
But the two seem to be... Would you agree that they seem to be conflated in the public eye?
Yes, sometimes deliberately. So obviously there are connections. So the rise of fires in the American West there's quite a few high quality papers that show you can attribute some of the rise of fires to climate. I believe that's correct. So then the air quality consequences you can think of as partly climate. But because it's very hard to sell people on solving a global cumulative pollutant, a lot of the environmental campaigners who are trying to help solve the climate problem focus on public health concerns. And so in these recent so-called debates that the so-called leaders of our countries had, where some so-called wise humans shout at each other about these topics, you'll hear complete conflation of those two things. So the red-haired humanoid who now runs the United States in a recent debate or pseudo-red-haired pseudo-humanoid did say explicitly about how we were making the air and water cleaner and answer response about climate change. The actual things he said about air and water are kind of true. It's not his doing, but it's true. But it completely dodges the question about climate change.
Mm-hmm.
And some of the other humans who are battling against that one will deliberately conflate all the air and water. So in the question that the female human on the team running against the red-haired human, her question to the Supreme Court nominee was all about water and air pollution when she was really asking about climate.
So what you're saying is that depending on who is asking the question, these things can be conflated in different ways in order to either muddy the waters or to shift attention.
But I would say what in sense is both parties have accepted the frame that focuses on air pollution. So the redhead human was deliberately saying, look, the air and water's got cleaner in America, which is true. I mean, it's true because of half a century of environmental regulation, not because of anything he did, but it's true. And the other humans, it's true, but it has nothing to do with climate. And the other humans are saying we should deal with climate because the air and water is dirty, which is actually kind of not true. It's not the reason to deal with climate. And I mean, they know that. They just think it's more successful to sell it that way. It's muddy.
Do you think that there are cases where the reason that the air and water appear to have been cleaned is because of the fact that the pollutants are not yet identified? Do you know what I mean? Like,
for sure. You mean we haven't noticed we're making a mess yet? Yeah, for sure. But I think it's important to say we really have objectively cleaned some things up. So we emit current cars for some important pollutants, current cars can be between 100 and 1,000 times better in terms of air pollutant per vehicle kilometer driven than they would have been when I was born. And for climate, they're worse. But for air pollution, they're better. And for the most famous global environmental problem, which was the ozone layer destruction problem, we have clearly turned the corner. Chlorine levels in the stratosphere are coming down because of a treaty that we made to all agree to stop putting chlorine in the stratosphere. So there are examples like that are real.
I appreciate that. What are you teaching?
Class on it's called Policy for an Engineered Planet. I work with a bunch of policy students to look at two hard to manage technologies, one of which is solar geoengineering, and the other one is something called gene drive for malaria control. and so it's good to work on both because they're so different.
I wish you told us. We have so many questions about the second one.
I'm not really an expert. I mean, I teach the background of it, but I bring other people in my class who are the real malaria gene drive experts in to give that background. But that gives you some sense. And no, I think these are really good questions. I think you obviously didn't ask that many of the kind of detailed technical questions for solar geoengineering, but on the other hand, it was a really good conversation about the larger, what it means and what the big issues are. So.
Well, hopefully one day we can talk to you again about the nitty-gritty details.
So you have to tell me though, what is the answer to the Fermi paradox? And why are you guys on a spaceship traveling towards Earth? Is that because you blew up your own planet?
No, we just got to recharge a drone that's stuck there. We haven't been there in like 6,000 years, so.
You guys started noticing the drone's batteries are going out a little bit, and so they're popping in and out.
But it hasn't. But what lessons do you have for us? Like did technological civilizations inevitably extinguish themselves?
If they don't learn to communicate, definitely.
Well, actually our boss would probably fire us if he knew we were talking right now.
That's definitely true.
I see. Okay. Well, we'll keep it on the QT. Thanks very much.
Thank you so much.
Thank you.
Bye.
Take care. Bye-bye.